Hi guys, welcome. So today's topic we're gonna be doing method of undetermined coefficient. So this method is the same method as solving the operators. So it's the same method that we're gonna use to solve the operators. So for now we're gonna use the method of undetermined. Then there's another method that we're gonna use later on, which is the operator method. They call it the operator method. So the first method, this one, method of undetermined, it's quite simple. So let me give you one example. So let's say you've got d squared y over dx squared plus 3dy plus 3dy, okay, plus 3dy over dx, and then plus 2y. Let's say it's equated to a for x. So I did a video earlier on, an introduction of the operator theorems. So please do watch that video. So the first thing that you need to do is to find the factors. So when you find the factors, they call this method or this step rather an auxiliary equation. So you have to change everything to m. So where there is dy over dx, you're gonna put m. dy over dx will be replaced by m. So you're going to have m squared plus 3m plus 2 equals to 0. So you're going to ignore this value. This value is your q. So you're going to ignore your q. You're going to ignore your q. When you find factors, you equate it to 0. Okay? So the next step is to factorize this. So the factors of 3 and 2. So 3 and 2, you're going to have to put 2 and 1. So it's going to be 2 and 1. And then they'll both be positive. Then equate it to 0. So the value of m1 will be equals to minus 1. And the value of m2 will be equals to minus 2. Okay. So this auxiliary equation, or these vectors rather, will help us to find the complementary function. Complementary function. And the abbreviation for this is CF. So this will help us to find the complementary function equation. So since your factors are not the same, the values of m, the equation that you're gonna use for your YCF is gonna be C1e to the power m1x plus C2e m2x, because the factors are not the same. So let's replace those values. So we're gonna get C1e minus x plus C2e minus 2x. So this is your complementary function equation. So remember, the whole point of solving this question is to get the y general solution. So you want to get the general equation. So the general equation will be a combination of your ypi plus your YCF. Then we already found a YCF, but we don't have the YPI. YPI is your particular integral equation. So that's what we're going to find now. So the next step is to find the YPI. So the YPI, in this case, the YPI is quite simple. So the YPI is very easy. So before I can find the YPI, let's say the factors of M. I'm just gonna do a few examples. Let's say M1 was equals to M2. Maybe let's say, for example, it was equals to 3. So let's say the factors were the same. The equation that we're gonna use, if the factors are the same for your YCF, you're gonna say C1E, then you write 3x plus C2E, 3x again. Just because they are the same, I'm gonna write it in blue. Just because your factors were the same, you just multiply by x. So the C2, you just multiply it with x because the factors are the same. So that's how you're gonna do your YCF if the factors are the same. Okay, that was just additional information. So now let's go to YPI. So remember, your YPI, you're gonna have to consider the YPI, you're gonna have to consider that 4x squared, the one on the right hand side. So the value of Q. So for your YPI all the time, you're gonna have to consider the value of Q. So YPI is equals to Q, which is that value on the other side. So check this. If your Q is equals to a quadratic equation like ax squared plus bx plus c, let's say we put the values. We know the value of a. Let's say the value of a in this case is 4x squared. Let's say it was plus maybe 3x plus 2, for example. So you'll get an equation like this. You have to convert it to alphabetical form. I'll say alphabetical form, or to a standard quadratic formula. You're gonna have to convert it to this format. So in our case, we only have 4x squared. We only have 4x squared. So we only have this one, 4x squared. So I was just adding the other values, 3x plus 2. This was just an example to show you that if you've got an equation like this, you just have to replace like 4 with a x squared, then you replace the 3 with bx, then you replace the 2 with c. So this was just an example. So in our case, we only gonna have ax squared. So our Q, to solve for YPI, we're gonna have to say YPI is equals to a replaces 4x squared. So you replace it with alphabetical form. Okay, I'll post more videos on the on this YPI, because YPI changes a lot. Sometimes it's a constant, sometimes it's a exponential, sometimes it's logarithmic like e to the power x, then sometimes it's a constant. It changes a lot. So I'll post make more videos on that. So in this case, we're just gonna say YPI is equals to ax squared. You don't write 4x squared, you write it in the alphabetical form. Then from there, because our original equation was d squared y dx squared plus 3 dy over dx plus 2y. You see this 2y, that y there, let me write it in blue. This y, it's your ypi. It's your ypi. So the value of ypi that you're gonna get that's the one that you're gonna put there. So this was equated to 4x squared. So look at this. You're looking for this unknown values, dy over dx, dy over dx, and then we're also looking for y. So this is what you're gonna do now. You're gonna have to differentiate this. You find the first derivative of that. So you're gonna have 2ax, and then you go again and find the second derivative. So the second derivative of that, you're gonna get 2a. Then from there, you're gonna have to substitute it back to the equation. It's easy. So let's go back to the equation. So you're gonna have where there is dy over dx squared. So you're gonna have 2a plus 3 into dy over dx, it's 2ax. Then plus 2 into, remember I said it's your ypi, that y there. You just say open bracket ax squared. Then will be equals to 4x squared. So let's just expand this further. So you have 2a plus 6ax plus 2ax squared equals to 4x squared. So here we're gonna consider the coefficients. We're gonna only consider the coefficients. So a coefficient is the number before a variable, this number. They call it a coefficient. So we're gonna look at those numbers. Then the coefficients that we're gonna consider the coefficients of the highest power. So we're using the power method. So the highest power on both sides, the right hand side and the left hand side, you compare which one has the highest power. So the highest power in this case is x squared. So we're just gonna write x squared there. And then we take the coefficients of x squared. So let's go where there is x squared. Let me highlight them. So the x squared is there and there. So it's 2a and 4. So you don't write the x squared because it's already a factor. So you're just going to say 2a is equals to 4. So I took the coefficients of x squared. Then your a will be equals to 2 when you divide. Then this a that we're looking for is the one that you're going to substitute back to the original equation, this equation of ypi there. So you're going to go back to ypi a squared. So where there is a, you're going to put 2. So your ypi equation finally is 2x squared. So that's your ypi equation. So now remember, the whole point of doing this was to find the ypi and ycf. Then you combine them. So the y general solution or general equation will be equals to ycf plus ypi. Then this will be equated to, you know, your ycf. So ycf, okay, let me take enough space here. So y general solution is equals to, so your ycf was c1e then minus x plus c2e minus 2x minus 2x. Yes, okay. Then you're gonna combine it with the ypi. Ypi is this one of 2x squared. So you just say 2x squared. Then that's how you find the general solution. This is how you do it. Okay, if you have any questions, please leave them on the comment section and then I'll attend you shortly. So, okay, we are done with this one. I hope this makes sense. So let's move to the next method. The next method is method of the operator. So basically we're gonna solve almost similar questions but using the method of the operators. Method of the operators. So you're finding basically you are finding a general solution. Finding general solution using this method. So you're finding general solution using method of the operators. This one, in order for you to solve an equation using method of the operators, you need to know the theorems. I posted a video on theorems. You need to know the theorems. If you don't know the theorems, it's gonna be a problem. If you don't know the theorems, it's gonna be a problem. So this is what I'm gonna do. We're gonna take a theorem with similar factors. We're gonna do what? We're gonna take a theorem that has similar factors. Yes, I said that. So we're gonna take a theorem with similar factors. So let's say we take like the one that has similar factors, like your d squared plus 4d plus 4k. Then y equals to e minus 3x cos 3x. So when I say similar factors, I mean this. Like in order for you to get the factors of this. So basically this is our auxiliary equation, equation. That's step number one. Auxiliary equation is when you find the factors. So you can have a plus 2 and a plus 2. Yes, I said it. So 2 times 2, you're going to get a 4. And then when you add them, you're going to get the 4d. So remember, when you find the auxiliary equation, you just put it to 0 because you want the factors. So d1 will be equals to d2 will be equals to 2 minus 2. Okay, then remember, we have to find the YCF. The YCF, and also remember that there's your YPI is the same as the previous one. But the difference is that here they used the operator method. That's why you have D. This D, sorry. That's why you have the D. This D means the operator, So they are using the operator method. You don't have M. So they are using D. The equation will come like this. D. That's why they're saying the operator method, D. So the Y that is outside the bracket, it's your YPI. So yeah, this one is quite complicated a bit. So to find the YCF, you're gonna say, since the factors are the same, I already told you, you're gonna say C1E. In this case, you're gonna have minus 2x plus C2E minus 2x. Remember, I told you, since the factors are the same, you just multiply with the x because the factors are the same. Then here's the trick now. Remember, after finding the complementary function, which is your CF, the next step, so let's say this is step A, you find the auxiliary equation, find the factors. Then number B, you find the complementary function. Then C, you're gonna have to find the PI, the particular integral. So to get the particular integral, you're gonna have to make the y from the original equation, this y, you're gonna have to make it the subject of the formula. So you're gonna have to divide. You're gonna say e minus 3x cos 3x divided by, from the original equation, it's d squared plus 4d plus 4. That's how you make ypi the subject of the formula. Okay, we're gonna go to the next slide to solve that ypi. So our ypi from the previous slide, let me just zoom this in so that it will be clear enough. So the ypi is equals to e negative 3x cos 3x divided by d squared plus 4d plus 4. So let me tell you something. You see, you are multiplying two variables there. It's a product. So you're multiplying two variables. And then whenever you see cos and e or sinh and e, cos and e or sinh and e, just know that you're going to have to change this all the time. The moment you see e and cos multiplied, or or sinh and e, just know that you're going to have to change them. So cos ax is equals to, you're going to get this from hyperbolic equations in your formula sheet. So just know that cos ax, you're going to have to change it to, e ax plus e minus ax over 2. So in our case, we'll have e 3x plus e minus 3x over 2. That's what we're gonna have. So this one is cos 3x. So your a is equals to the 3 that is there. Then since we are here, we're gonna take this and put it back to the original equation. So your ypi will be equals to e minus 3x. You see, look at this, open bracket, e 3x plus e minus 3x. So just to make it nicer, put d squared there plus 4d plus 4 outside. Let's make this bracket bigger. Let's just do this. Then divided by 2. Okay, so now we're gonna remove the brackets. So we're gonna multiply everything with this. We're gonna multiply everything out. So the best thing to do here, since you have got 1 over 2, remember there's 1 there, so you can take it outside. So you're gonna do this. This is the easiest way of solving it. So you're gonna take the factor out of 1 over 2, then you're gonna multiply everything in. So you're gonna multiply this in. Remember the 2 is it's a factor for all of them. for both e to the power 3x plus e to the power minus 3x. So you just factor it out. That's the quickest way to do it. So when you multiply e to the power minus 3x times e to the power 3x, multiplying the powers of the same base, you add the exponents. So you're going to get e to the power 0 there. Then also divide the whole thing as d squared plus 4d plus 4. Then you're going to get plus e. Then when you multiply these two, you add the exponents. So you're going to get minus 6x. Then that's it. So you're going to get 1 over 2. Then you see there's nothing to simplify there. There's nothing you can do. So look at this. I already done this on the introduction. When you see that these two are using the same theorem, e to the power 0 and e to the power minus 6, the moment you see e, they use the same theorem. So since they use the same theorem, there's no need for you to split this LCM, this one. There's no need for you to split it. Let's say if they were not using the same theorem, you're gonna say e to the power 0 divided by d squared plus 4d plus 4 plus e to the power minus 6x over d squared plus 4d plus 4. If they were not using the same theorem, you're gonna do this. But now since they are using the same theorem, you can just put them in one place. So you've got e to the power 0. I know that e to the power 0 is 1. A constant. The moment you see, let's say e, let me not put e. This is just an example. I'm just giving you guys extra information. Example. Let's say you have 5 over d squared plus 4d plus 4. The moment you see a constant, just add e to the power 0, because e to the power 0 is equals to 1. So it doesn't have any impact. The reason why I'm doing this is so that you can be able to solve this question. And remember, the theorem for e, this is like, let me write it nicely, basically. This is more like 0 to the power, it's e to the power 0 x. So remember, e, it's ax. So in this case, if you are saying e to the power 0x, it means 1. So your a, the value of a is equals to 0. So a is equals to 0. And remember, if a is equals to 0, it's also equals to d, the theorem for e. The theorem for e says d is equals to a, or a is equals to d. So you're going to go back here and say 5 over, remember it's e o x. You're going to put 0 squared, you apply the theorem for e. 4 times 0 plus 4. Then your final answer will be 5 over 4. Okay, so that's what we're going to do there. Same thing here. The moment you see a number, just put e to the power 0x. So you can just add 0x there to make it nicer. So you're going to have 1 over, for the first one, you're going to get, okay, the numbers are going to be different. So just say 1 over 0 squared plus 4, 0 plus 4, and then plus e to the power minus 6x divided by minus 6 squared plus 4 into minus 6 plus 4. Okay, then you're gonna get 1 over 2 as your answer. So okay, let's remove this one. We don't need this. I was just showing you that you're gonna split it like that. Okay, so from here you come there, you're gonna have ypi equals to 1 over 2, 1 over, everything is gonna be 0, so it's 1 over 4, plus e to the power minus 6x divided by, so you're gonna get 36, then 6 times 4, you're gonna get minus 24, minus 24 plus 4. And then your final answer will be, so now the factor, this one, I'll multiply everything with that. So I'll get 1 over 8 for the first one, plus e to the power minus 6x divided by, so here I'm gonna add, so it's minus 24 plus 4. So 4 minus 24, you'll get minus 20. Then you're gonna say 36 minus 20. So you're gonna say 36 minus 20, you'll get 16. And then 16 times 2. 16 times 2, you're gonna get 32. So remember, this 1 over 2 multiplies everything. So here, let me write with blue. So in here, I got 16. Because it was 36 minus 20. Then I got 16. 16 times 2, it's this. So this will be your final answer for your YPI. This one. This is your YPI. So you're gonna take this YPI back to that equation for YGS. So you're gonna say YGS, Y general solution, is equal to YPI plus YCF, or YCF plus YPI. It doesn't matter which one comes first. So Y general solution will be equal to C1E. Remember, you've got minus 2x plus C2E minus 2x times C there times x, because they've got similar factors. And then you're gonna say plus 1 over, you add the YPI now. It was 1 over 8, if I'm not mistaken. 1 over 8 over 32. So I've got this section, YPI. This section, YCF. And that's how we solve it, guys. Just like that. That's how you're gonna solve your question if you come across this question. So thank you for watching, guys. I'll post more videos on this. If you need extra lessons, I'll just leave my numbers there. You'll just text me on WhatsApp. Thank you for watching, guys.